Okay, so welcome. This is just a follow-up to the online quiz we took the other day. You're going to have a hard copy of that. And so if you got it right, there's no need to listen to my explanations. But if you happen to struggle with a problem or you missed it for whatever reason, you should be able to fast forward to the ones you missed, and there will be an explanation. I'm going to try as hard as I can not to just give away the answer. Sometimes that's hard, but hopefully it'll be enough so you can do the work, which I need you to do on a hard copy, which I'll be handing out, of the exact same quiz that you took online. And so I need you to do the work for the ones you missed and show your work. In order to get full credit, if you do that, you should manage to get a pretty good grade. So let's get started. All right, so number one, Shayna can swim 12 laps every 30 minutes. How many laps can she swim in 120 minutes? Okay, so one way to think about this is, okay, she can swim 12 laps in 30 minutes, okay? Well, there are a certain number of 30-minute periods, of 30-minute periods contained within 220 minutes. I think we can all sort of visualize that. We know within 220 minutes there are so many 30-minute sections of that, right? So if we determine how many 30-minute sections are in our 220 minutes, then we'll know how many times she can swim 12 laps, right? So that's it. We just have to determine how many 30-minute sections are in our 220 minutes. Well, how do we do that? We do that by dividing. So we're just going to take 220 divided by 30. We get a certain number, okay? Then we can multiply that times the number of laps that we know she can swim in 12 minutes. Excuse me, we multiply that times 12 because we know she swims 12 laps every 30 minutes. So it's basically she's swimming 12 laps every 30 minutes. Well, a certain amount of 30-minute sections or 30-minute time periods go by in 220 minutes. We just have to figure out how many of those time periods go by. Once we know that, we know every time one of those time periods went by, we can add another 12 in there, okay? So we basically, that's one way to think about it. Another way is to use ratios. By all means, we use ratios. And the way we use ratios is we make fractions. But the units have to be the same. For instance, it needs to be laps over minutes, okay? So we're going to say that we're going to assume she always swims the same speed. She always swims 12 laps per minute, or 12 laps every 30 minutes, okay? We're just going to assume that. So as long as we keep our laps on top and our minutes on bottom of the fraction bar, and we know that the rate stays the same, okay, we can say, well, 12 laps, 30 minutes, that's also going to equal some number of laps, which we don't know, so we're going to say X number of laps in 220 minutes. Now, a neat thing we can do to solve for whatever this X is, if you have two fractions or two ratios that are the same, you can solve, and you have one whole fraction and just part of the other fraction, you can always solve for the missing part. So basically if you have two fractions, there are four things. There's a top and a bottom on each one of them. If you have three out of the four things, you can always solve for that missing fourth, and you can do that by cross multiplying. So you would multiply the 12 times the 220, set that equal, okay, that equals the 30 times the x. Okay? Now we can do the math. I'm not sure how much I'll do of this for you. I think you know how to multiply 12 times 220. You would do that. You would come up with some kind of number after you multiply the 12 times 220, and that would still equal whatever you would get by doing that would still equal 30x. Now we want to know what x is, so if x is being multiplied by 30, we're back to the same thing. In order to discover what x is, we want to get x by itself. So if it's being multiplied by 30, we would divide by 30. And the way you do that is you just make a fraction out of it, and you place the 30 on the bottom, which is what you would do over here. So you would go ahead and multiply it, so you would know what that number is. You're dividing both sides by 30, so that's keeping everything equal. Then you're going to get something over here, and that's going to equal x. Okay, and x, right, if we go back up here, we know that it's laps over minutes, and laps is what we're looking for, so this x should equal one of these. Okay, so hopefully that helps out on that one. We'll go to number 2. Ratio of boys to girls. Okay, there are 30 students in the class. 16 of them are boys. What is the ratio of girls to boys? Okay, so if there's 30 students and 16 of them are boys, that means the rest are girls. So all we got to do is subtract 16 from 30. So you can do that on your own, but you'll come up with 14, I'm fairly certain. So that means we have 16 boys, 14 girls. That's what we have. So what is the ratio of girls to boys? Now, we have to know when things are given in a certain order what to write on top and what to write on bottom of a fraction. So when they say girls to boys, I believe that the first one is written on top, so it's 14 over 16. So girls to boys, 14 over 16. I'm not going to go into fractions. I'm going to sort of leave that one to you. But 14 over 16 can be reduced to a certain fraction that is contained within the answer. Hopefully that helps out on that one. Okay, so in question 2, what is the ratio of boys to all students? Okay, boys to all students. Well, how many all students was there? Okay, there was 30. How many boys was there? 16, if I remember correctly. Okay? So this can be reduced. 16 over 30 is the ratio. It can be reduced down to a simpler form. Okay? And as a matter of fact, that helps us answer which one comes first. The first one listed goes on top, okay, to all students. So, because that's the only one that actually works out. So we know that one now. Okay, so you just have to know how to reduce fractions. I can help you out with that. I'm not going to go into that in this video on how to reduce fractions, but essentially you can just start dividing. There are a lot of ways to do it. A lot of people like to find the largest number that will go into both of these. That's fine. Sometimes that's not going to occur to you. The essential thing is you can divide the top and the bottom by the same number. And you can just start by whatever you think. Okay, whatever you think will work. 2 works a lot of the times. Or if you see a number that you know 5 will go into, or you can divide it by 5 evenly, you do that. In this case, 2 might be a good choice. But as long as you divide the top and the bottom both by the same number, you can reduce the fraction. And eventually you get down to 2 numbers that cannot be divided evenly by the same number, and then it's reduced to the lowest terms. Okay, so hopefully that's enough to answer that one. Okay, 4. Victor buys 4 cans of soup for $3.60. What is the unit rate? Okay, so he buys 4, he just hands the person $3.60 and winds up with 4 cans of soup. Well, each one of those cans of soup costs a certain amount. And we want to know how much. Well, I mean, really, we're going to divide to get this answer. But you're literally dividing up the money you spend amongst the cans of soup. And that's going to tell you how much each can of soup costs. So if you can do that, then you can figure out how much it costs per can. So you can divide $3.60 by 4, and that should give you your answer. And you can use a calculator on these. So I think everyone should be able to handle that. If you are struggling with it, feel free to go ahead and raise your hand, and I will help you out with it. Okay, so number 5, is the following proportional? Well, first of all, what does proportional mean? Okay, if you got this one wrong, you may not know what proportional means. What proportional means is, okay, 6 has a certain relationship to 8, okay? 6 is a certain size number, and 8 is a certain size number, okay? And they have a certain relationship to each other, okay? Now, you can think of it in terms of, okay, you've got, just so one way to think about it is, let's say you've got 2 little children here. Okay, that's a bad stick figure. But these are both little children. Terrible stick figures. Okay? Well, one is bigger than the other. Okay? And they have a certain relationship. Okay, how much bigger? A certain amount bigger. Okay, well, you could have 2 adults. Okay, 2 adults, and one adult can be bigger than the other adult. That can happen too. Okay, but even though they're both smaller, in some kind of weird way, or some kind of way, they kind of, even though both the children are smaller and the adults are both bigger, they differ sort of in the same amount. It's not the same amount, but it's the same proportion. They're different, but they're different in the same proportion, okay? As in, like, maybe this kid is 2 feet tall and this kid is 3 feet tall. Well, maybe this adult would be kind of a short adult, but he might be 4 feet tall, and this other one might be 6 feet tall. Now you can kind of see, if we multiply both of these numbers, both of these by 2, so if we multiply 2 by 2, we get 4, and if we multiply 3 by 2, we get 6. Okay, so by a factor of 2, if we multiply both of these by 2, we wind up with the height of the adult. So you can see that there's some kind of relationship here, and that's a proportional relationship. They don't differ by the same amount, but they differ in a similar way. Okay, I guess that's the best way to put it. They differ in a similar way. So that's kind of what being proportional means, is things differ in a similar way. Well, are 6 over 8 or 6/8 proportional to 20 over 24? Well, is there anything that we can multiply 6 and 8 to get 20 and 24? Okay, so like, I know you can multiply 8 by 3, and that gives you 24. Can you multiply 6 by 3, and will that give you 20? Actually, no, it will not. So they are not proportional. You can also divide. If you could find a number, the same number that you could divide both 20 and 24 by, and that would reduce down to 6 over 8, and they would be proportional. But you can stare at that number for a long time and you're not going to come up with anything. That's pretty much the best way, things being proportional just means that you could multiply both of the things by the same number. I'll give you an example of what would have been proportional is if it was 6 over 8, and we'll stay with the 24, but instead of 20, it was 18. Okay? Well, that is proportional because you can multiply both 6 and 8 by the number 3, and that will yield both 18 and 24. So that would be proportional, but this particular number is not proportional. So I went ahead and gave that one away, but hopefully that helps you out. Okay, so complete the table below by solving for the missing values. When 2 over x equals x over y. So, again, 2 over x is going to equal x over y. They're going to be proportional. The two any fractions, we know fractions can be the same but look different. We know that. They can have different numbers but be actually the same fractions because fractions can be reduced. Or fractions can be made larger by multiplying the top and the bottom by the same number. Or the numbers involved can look larger but it's actually the same value. Okay, so the way we would do 6 through 10 is they're giving you the x or the y, okay? So we've got 2 over 6, okay? So if they give you the x, okay, that means they're giving you that. They're giving you the one that corresponds to 2 because the x corresponds to 2, the y corresponds to 6. So that's the one they're giving you. So in each one of these, like number 6, I'll do number 6 for you, and you can do the rest of them yourself. You would just set up a proportion, which are basically 2 equal fractions, and we know, they look different, obviously. They have different numbers, but they are the same fraction. So what do we do to 2 to turn it into 4? Well, we multiply it by 2. 2 times 2 is 4. So if that's what we do to the top, that's what we must do to the bottom in order for it to remain proportional, okay? So we multiply 2 times 6, it gives us 12. So this first one is going to be 12, okay? And you can see that is one of the answer choices for 6. So I did 6 for you, but if you were going to set up, I'll skip down. They're always going to be proportional to this 2, 6, okay? Because x over y, they're just giving you, x over y. And they're going to give you either x or y. So let's take 9 and actually give us y. Okay? So instead of x over y, we would say 2 over 6. And they give us the y. So it's something over 33. Okay? Okay, I'm back. Sorry about that. Okay, same thing. There is some number, you can multiply 6 by something to get 33. Oh, change colors. Go back to black. So, now, how do you determine what you can multiply 6 by to get 33? Okay, well, you can actually just divide 33 by 6. Okay, so you've got a calculator. What you will find is you come up with 5.5. So actually 6 multiplied by 5.5 equals 33. Okay, so you would just multiply the top by 5.5 and that would give you something. Okay, so that is basically how you do 6 through 10. Shouldn't be too much of a problem. Another way you can look at this one is that...
Citlali, if you're in the building, please come to the main office. Citlali.
You know,
Citlali. Ahora. Dile.
Citlali, come to the office. Citlali, come to the office.
yep, there you go. You can have that for free. A little bit of comedy there, after school comedy, the custodial staff. Anyway, you can see that 2 would go into 6 3 times. 6 is 3 times as big as 2, right? Because 3 times 2 equals 6. Well, what could you multiply times 3 to get 33? Okay, that's another way that you can find out if things are proportional. You can do it either way, but that way might be a little easier here if you're just sort of thinking about it. Well, you know, that might give you that instead of having to divide and work with decimals and everything. So anyway, let's continue on. All right, so here we just have some just straightforward, this is laps over minutes. So we can do 9 laps in 3 minutes. So what we're missing is the number of minutes. We can do 9 laps in 3 minutes. What about 27 laps? How many minutes is that going to take us? Well, we know we can cross multiply. Okay, so we multiply the 9 times the x, 9 times x, and we set it equal to 3 times 27. Okay, now we're looking for x. Once we know x, then we know the minutes. We know the time. So we would basically just, I'm going to leave it to you to plug that into your calculator. You can do that. But whatever you come up with, to get this x by itself, x is being multiplied by 9. So in order to undo that, you would divide by 9. Divide both sides by 9. And that's going to give you something for x. Okay? That is how you do that one. As soon as you get in the habit of these units, it's making sure that it's so many whatever over so many whatever, and making sure whatever you're setting equal to it has the laps on top in this case, or the whatever, miles on top, or minutes on top, or whatever. They just have to be the same. It has to be laps over minutes, laps over minutes. Okay? And then you can just solve for this. If you know that the two fractions are proportional, are they equal? As long as you know that, you can set them up, you can cross multiply, you can solve for x, and that's going to give you your minutes. Okay? So hopefully that helps out on that one. Okay, so number 12. Here we've got, it looks like dollars over newspapers. So $30 gets you 25 newspapers. Some amount of money gets you 5 newspapers. Same thing, as long as we have dollars over newspapers and we're keeping our units the same, dollars over newspapers, we can just cross multiply. We can go 30 times 5 equals 25 times x. Okay, and you can do this in your calculator, 30 times 5. If we want to get x by itself, we're going to divide by 25, so you would actually divide both sides by 25. That's going to give you this x by itself. Okay? So hopefully the mechanics of that are starting to make sense to you. You know, feel free to ask me in class, and I can go over it in a little bit more detail. But the cross multiplication method, once, like I said, once you establish the ratios and you know that they're equal or proportional, cross multiplication makes it really easy, and you just solve for your variable. Car travels 300 miles on 15 gallons. What is the miles per gallon? Okay, so basically, each gallon gives you so many miles, but they don't give us just 1 gallon. They tell us how far we travel on 15 gallons. Well, you can think about it. Each one of these gallons right here accounts for a certain number of these miles. Each one of them contributes a certain number to that certain number of miles to the 300 miles. Well, if there's 15 of them, and you know each one of them contributes a certain number of miles to the 300 miles, you can simply take your 300 and divide it by 15, divided by the number of miles. That will give you your miles per gallon. Okay, and that's what they're asking for. Miles per gallon, miles over gallon. If you set it up, you do miles over gallon. You just divide them, and that's going to give you, you know, when they write miles per gallon, you write like that, anything, you know. Anything you write per something else, it's sort of like that. You just write it like a fraction. So miles per gallon, you're going to get some kind of miles per gallon. It should be good on that one. Okay, 35% of $140. Okay, now what we need to know is how to convert. Maybe we've got a calculator with a percent button, maybe not, but all calculators will do decimals, so we must know how to convert percents to decimals. So 35%, the way you convert a percent to decimals every single time is pretend there's a decimal here, move it 2 places to the left. Only 2 places, and you do it every time. So if you move it 2 places to the left, that gives you 0.35, or a lot of times we write 0.35. And this decimal is equal to that percent. Excuse me. So now all we have to do is we multiply this decimal times 140, and that will give us that will give us 0.35 or 0.35 or 35 hundredths. It can be referred to, I think maybe your science teacher teaches you to do it that way, which is good. That is a way people talk about it a lot. I have no problem with 0.35, but that's it, and that is going to give you one of these. I will leave it up to you to do the math, but you just need to know converting a percent to a decimal involves the same thing every time. If you're given 5,000%, let's say, okay, you still, if you were to convert it to a decimal, okay, 5,000% equals 50. Okay, so if you were to get 5,000% of something, you would be multiplying it times 50. Okay, it's always twice to the left every time. Even if the situation could exist where you could have one, or you could have to say 15.34%. Okay, or 35%, excuse me. Well, if you wanted to convert that to a decimal, you would still move it 2 places to the left, which would be 0.1535. Okay? So, and that's just the rule every time you're changing a percent to a decimal. So, I will leave that one to you for you to finish. A family pays Number 15, a family pays $19 a month for internet access. Next month, the cost will increase by 5%. After the increase, what will the new cost be? So, there's a couple ways we can do this. We can just figure out, okay, we know they pay 19, and hopefully after the one we just did, we know how to convert a percent to a decimal, which is to move, pretend there's a decimal right here to the right and move it 2 places. If there's not a place, we add a 0, okay? So 5% in decimal form is 0.05. We could multiply 0.05 times 19. Okay, we could do that. That would give us something. I will leave that to you to do. You'll have a calculator. And we're increasing what they're already paying. They're still going to have to pay that $19, but they're going to have to pay the 5% more as well. So whatever we would get here, we would just add it to the $19. There's kind of a shortcut or a different way to do this, in that you can just you can convert it to the decimal. So you got your 0.05. And then you can put a 1 there. Because we know if we multiply anything times 1, it just produces that same thing again. So if we multiply that times 19, that would be the same as multiplying it by the 0.05 and then adding it back to the 19, okay, like that. Well, that 1 sort of keeps the 19 there, but it also multiplies it times the 0.05, and in both cases you will get the same answer. If you ever want it, something, if you're paying a certain amount and it increases a certain percent, an easy way to do it is just convert the percent to a decimal like we did here, but then just put 1 in front of the decimal. So, just like we did right there. And multiply it times whatever you're currently paying. Okay, so which triangle is similar to the following? Similar, okay? When you see similar, think proportional, okay? So this 6, we've already talked about a number's going to have a certain relationship to each other. Well, the 6 and the 15 have a certain relationship. The 6 is a certain size in relation to the 15. Well, okay. What does that mean? It means that there can be some other numbers that share that same sort of relationship. That's proportional relationship. Okay? Now, the difference between 15 and 6 is like 9. Okay? Well, the difference between the other two numbers, in order to be proportional, doesn't mean that the difference would be 9. It just means that the difference would create the same fraction when you put them over each other. So we'll just start like this. So I think the best way to do it is to create a fraction 6/15. Now we're looking for, okay, when you're looking for figures, we put the 6 here and the 15 here, okay, because the 6 was from this shorter side and the 15 from this longer side. So whenever we create other fractions to see if they're proportional, we have to put the shorter side on top and this longer side on the bottom, okay, just like we did. So, so let's see here. How can we do this? We know that, well, we can just try them out. We can see which ones are proportional. So is it going to be 4 over 12? That's your short side, and that's your long side. Well, how do we turn 4 into 6? We could multiply it by 1.5, right? 1.5. Well, if we multiply 12 times 1.5, we do not get 15, I'm pretty sure. So they are not proportional. Essentially what you're doing, though, is you want to look at these You want to be able to multiply or divide both of these numbers by the same number and then get these numbers if it will work out, okay? So if you look at these two numbers, is there a single number you could pick? It could be anything, but you have to multiply them both by the same. That would give you these numbers. And when you find that out, then you have what is called a similar shape, or the triangles are similar. And similar really just means they're proportional to each other, okay? The lengths of the sides are proportional. They create the same exact shape, but just different scale. They've been scaled up or scaled down. Maybe that is enough to help you with that one. That's what we're looking for, though. When we're looking for similar things, we're looking for, okay, I can multiply or divide the sides, the corresponding sides. It has to be the short side, correspond to the short side, and the long side has to correspond to the long side. You can multiply them by the same number or divide them by the same number and produce these right here. Excuse me, these numbers. Okay, if you find that you are able to do that, if you are able to find a number to multiply both of these by that gives you both of these, okay, any of these, then you have found a similar figure. So hopefully that's enough on that one. Okay, so two rectangles are similar. One has a length of 6 inches and a perimeter of 24 inches. The other has a length of 7 inches. What is the perimeter of the rectangle? Okay, so two rectangles are similar. One has a length of 6 inches. So we know it's a rectangle. Okay. We know it has a length of 6 inches. Okay. Which means it has two sides that are 6 inches. Okay. Perimeter of 24 inches. Well, we know that if we're talking about perimeter, we're talking about, it goes around. The perimeter is just the exterior, just the outside of it, basically, is the perimeter. Okay, well, if we know that it has a length of 6 inches and the perimeter, okay, so there's a length of 6 inches, perimeter of 24. Well, we know what rectangles look like, so we know if it has a length of 6 inches, it has two sides that are 6 inches. Well, all the sum of the sides make up the perimeter, right? When we add all the sides up, and we add this side, 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 they make up 24. Well, when we add this side and this side, that's going to make up 12. Okay? Well, we've got 12 more to go to get to 24, but we know that this side over here and this side over here must equal each other. If we've got 12 more to go, that means this rectangle is actually a square with all sides being 6 inches. Okay? That is what that means. So the other has a length of 7 inches. What is the perimeter of this rectangle? So, since we know that they're similar, we know that the sides are going to have the same relationship to each other. So, this one's not going to be too bad. And 7, 7, 7, 7. Okay, and I'll let you do the math from there with the calculator, but hopefully that will make it a little easier for you. Okay, which trapezoid is similar to the following trapezoids? Okay, again, we're just looking for the relationship. Is there anything that we can multiply this number and this number by some number we pick? It has to be the same number. That's going to make them equal these right here. And it may not be a whole number. It could be a decimal. or we might divide as well. That could work too. Or another way you can look at it is this number goes into this number a certain amount of times. Looks like 3 times. That defines the relationship as well. So is there one of these trapezoids that has that sort of relationship? Okay, so that's what you're looking for. You're looking to be able to, whoops, excuse me. When you're looking for things that are similar, which is very closely related to the word proportional, you're looking to take 2 numbers, at least 2, and multiply or divide them by some other number, just one number, and then that's going to spit out some other numbers. So, but it's got to be the same number. So whatever we're going to multiply or maybe divide, possibly whatever, this number by something, and then we do the same thing to this number, and then that's going to spit out maybe these numbers, maybe not. I'm going to leave that up to you. But another way to establish the relationship is we can clearly see that we know that there's 3 4s that fit inside of 12, and that also defines that relationship, that proportional relationship. So that's another thing we can use. Does that dynamic exist in any of these other ones? Are there 3 5s in 10? No, there's not. So I'll go ahead and tell you B is not one of the answers. I'll give you that much. So hopefully that helps out on that one. Okay, if the scale factor is 2.5 to 1, what is the height of a model that is 6.2 feet tall? So the scale factor, 2.5 to 1, what is the height of a model that is 6.2 feet tall? Okay, so this one is written a little confusing. I would have liked to have seen some units here. That would make it a little bit more clear, but we really don't need that because what we know is a model. Interesting. So there, we have a model of something. We've modeled something, and it's 6.2 feet tall. Okay? I'm reading this. So whatever we have modeled, maybe we've modeled a Christmas tree. I don't know. But whatever it is, it's 6.2 feet tall. So the scale factor is 2.5 to every 1 foot of whatever the thing actually is. Okay? So this has been scaled Okay, I'm back. Yeah, this one threw me off a little bit. I definitely don't blame you if you got it wrong because it really doesn't make any sense. You would typically not write something like this. This is very confusing. But we're going to go with it. Sometimes it's fun to figure things out. So I don't know why you would make a 15 or some larger model of something that is already kind of large. This doesn't really make any sense. But so basically they're saying for every 1 foot that's contained in your model, there's 2.5 feet in whatever you're modeling. Some, maybe you decided to model a large Christmas tree. I'm just going to go ahead and do this one for us. So we decided to model some larger Christmas tree. And it ended up, we used the scale of 2.5 to 1. So we know that for every 1 foot that's in our model, we have 2.5 feet that will be our actual Christmas tree, we'll say. So how do we do that? All we do is multiply 6.2 times 2.5, and what you're going to come up with is 15.5 feet. Again, very bizarre. Don't blame you if you got that one wrong. That one is a weird one. But typically you would see something like, a map is drawn to a scale of, say, 20, and they would give you units. So you would see like 25 miles to 1 inch on the map. That way you would know if you had some little map, say, 1 little inch on this map would actually mean 25 miles in reality. So if you were walking from here to here on the map, you would actually be walking 25 miles would be that distance. So anyway, bizarre question, don't like it, but we'll move on. Okay, so find the value of x in the similar figure. Well, what do we know about similar figures? We know that their sides are proportional, right? So if we know things are proportional, then that allows us to make fractions that we know are equal as long as we put the sides, the long side has to be on top, or vice versa, but we have to be consistent. So I put the long side on top here, so I'm going to put the long side on top here, and then put 9. Then we can do our little cross multiplication trick, which will give us, where can I write this? Let's see. Cross multiply this, 9 times 45, and then cross multiply this way, it equals 15x. Then we solve for x. Okay, we just do, and then when we know what x is, we know what the answer is. We may, feel free if you're having problems with the solving for the x part, which is basically just, you would do whatever this is, 9 times 45 is some number, whatever you came up with, but eventually to get the x by itself, so we know what x actually is, since it's being multiplied by 15, we have to do the opposite of multiplication, which is division. The way we do that is we just put it over 15, or we divide it by 15, which means we put 15 in the denominator of the fraction, which that would divide out to 1 and leave x by itself. So whatever 9 times 45 is some number, you divide by 15, that's going to probably give you your answer. So, I think that is it. Yep. So hopefully all this helps and didn't give away too much. So what I need you to do is just complete the ones that you got wrong, turn it in, and that's all she wrote.